Okay, Baha question number 15. The parachutist jumps out of a plane and falls for 10 seconds. Then at this point, after a period of time, or t seconds, opens the parachute. So for the first part, acceleration is g. Then once the parachute's open, it's g minus kv. So I'm assuming that t is positive going down because my g in the acceleration was given as a positive g, and the parachute, which would have gone resistance against the direction of motion, is negative. If the terminal velocity is vt and the parachute opens at the speed of the descent at 1.5 vts, so when the parachute's opened, u is going to be 1.5 vt. Since acceleration is g minus vt, then terminal velocity will be when acceleration is 0. So terminal velocity is g on k. So I think that my u is 3g on 2k, and I want to fall until my v equals 1.1 g on k. And what am I after? I'm after the time it takes to fall from 1.5 times the terminal velocity to 1.1 times the terminal velocity. Okay, so I've got acceleration is g minus kv. I can flip it upside down. I want the time that the velocity goes from 3g on 2k to 1.1 g on k. And that's 1 over g. Now, what does it look like by hand? It looks like this, looks like this, looks like this, and you end up with log 1 on k log base e of 5. What does it look on the class pad? 1.1 g on k, 3g on 2k, 1 on gk on x dx, and I get the same answer. So the time should equal 1 on k log base e of 5, which gives me two possible answers. I need to find the distance. Okay, so I need to do a different substitution for acceleration because I want to know x. So I'm going to use v dv dx equals g minus kv. So rearranging this, flipping it upside down, the v goes to the top, that goes to the bottom. My x will be what will be. Now, if I go from this velocity to this velocity, it should give me the distance. So on the calculator, all I've had to do is to put an x up here. I've still got the same terminals. When I press x here, I get that distance, and that distance should be the same as a. A is going to be my answer.